Hi everyone. As part of this topic, we'll start with the first topic that is high-level RAG architecture. So, let's go through that. What is RAG? So before we understand what is RAG, let's try to understand why RAG. Why we need RAG to generate any answer. So, let's suppose you have this PDF, okay, and now you want LLM to generate or to search something from this PDF. So I have just created one Streamlit dashboard where you go and upload this PDF. It will generate some answer. So let's go and upload this PDF and let's pick something from this document. So let's suppose poor quality sound. Okay, so let's suppose I'll ask one question: how to fix poor quality sound? Now what it is doing? So behind Gemini is running. It is going and scanning entire content in this PDF, and then it is respond coming up with the answer. So that answer is something coming from this section: clean the disk, whatever. Okay, so now what happened? Okay, I have a PDF of 16 page, and then I uploaded that document and it generated the answer by scanning the entire PDF content. So this is just 16 page PDF, but in real scenario you might have multiple PDF. One might have, let's suppose 1,000 pages, or you have 10 PDF of 100 pages each. So now let's suppose if you have to generate an answer, you go and upload all those 10 documents, then LLM has to go and scan the entire document. First thing, it is gonna take time. Second thing, it might hallucinate. Third scenario is, okay, even if it generates good answer, it is scanning the entire text in the PDF, which will be definitely more cost. It will produce more cost. So now to come handle those scenario, let's suppose if you are able to figure out, okay, whatever question the user is asking, so how to fix poor quality sound, okay, it's available in this page. Let's suppose, okay, you have a way to figure it out. Okay, the user question, whatever they're asking, it's available in this page, or maybe 3 or 4 page. Okay, something similar is existing in those 4 pages. And then instead of passing only instead of passing entire PDF content, if you go and just pass that particular 2 or 3 page, then you ask LM to generate the answer. The benefit will be it will generate better answer. Chances of hallucination is less because you're just giving only those content from PDF where exactly knowledge reside for the question whatever user is asking. Third will be, okay, you're passing less number of words, so less number of token, cost will be less. So this is what RAG is. So RAG is, okay, you build a system which retrieves relevant information from the stored knowledge base. So whatever knowledge base you have, like in this case, let's suppose PDF, it try to first, before we go and pass that to LLM, it go and get the closest match. Okay, hey, these are the 3 pages which have similar content, whatever user is asking, and then pass that information. So to language model LLM, it is passing only those pages, okay, those 3 and 2 pages along with what user is asking, and then generate a response. So first thing, okay, it goes and retrieve only the closest chunk, whatever chunk in the sense, the closest pages where we have some information related to that particular user query. And then instead of passing the entire PDF, it goes and pass only those pages to LLM, and then it try to generate the response. So this is what RAG stands for. And since it is too much optimized, it takes less cost, chances of hallucination is more, chance of hallucination is less, and then quality of response is better. So that's why, in case of any document-based answering and all, RAG is the one which is having higher preference over scanning the entire PDF. So RAG has two components. One is data processing. Second is that RAG architecture. So data processing in the sense like, okay, you might have PDF, you might have image, you have a lot of things, right? So you go and consume .pdf. So let's suppose in this case, okay, let's suppose you have a PDF. So what you do, okay, you go try to pass all the text and all the image and store that in a database. So how it works is like, okay, you have a PDF, let's suppose 16-page PDF, then you create, let's suppose 16 chunk, embed it. So these are the things which, what is embedding model, and these are the things which we are going to cover in the next future section. But now let's suppose, okay, you got a PDF, split PDF into multiple chunks. Okay, this is page one, this is page two, this is page two, page four, and you store that in a database. Something like that you can do. So let's suppose This is a PDF. Okay. Page one, text. How are you? Let's suppose page two. This is page one. This is page two. This is page three. Hello. So it's like whatever text is there in that particular page, right? That is something you are storing in this. Hi. Till, let's suppose you do it till page 16. Hello. Again, let's suppose hello, how are you? Something like this. So first thing what you do is, okay, you get all the raw content, split that into multiple chunks. So by chunk, what you mean? Okay, based on some length and all, let's say in this case, for each page, you create one text chunk over here and then embed it. So embedded something will cover in less future section. For now, you forget that term and store that in vector database. So whatever chunk you have created, right, you store in one database. Okay, that is your data processing part. So you got a PDF, you split that into multiple chunk, and then you are going to store that in database. So these all things we are going to implement. We are going to cover each component separately first, and then we'll go through full end-to-end implementation. So I'm just explaining you the each different content. So first will be like RAG architecture, then embedding model. So in the way like each component we are going to explore, we are going to learn like how each component works, and then later we are going to build that end-to-end architecture. So data processing is good. Now coming to RAG architecture. So let's suppose there is a user query. So in this case, let's suppose we ask, okay, how to fix poor quality sound. That will get converted into some vector using embedding model, which we are going to cover in future. What it does is, okay, whatever user query question comes, right? So now one scenario, okay, you pass entire page to LLM and then generate the answer. Second scenario, okay, you try to figure out using embedding model. That's the role of embedding model, which we will be covering. So what embedding model does, it will give you, hey, whatever user is asking, those things are available only in page one and page two. So this is what embedding model is doing. User query is coming. Embedding model is kind of scanning. You embed a user query and then scan in vector database and get the top k relevance in top k in the sense. Okay, these. So it's up to you how many chunks you want to retrieve. So let's say you want to retrieve 4 or 5. So let's say in this case we are going with only 2 chunks. So it will give you, hey, these two are the closest chunk which has details whatever user is asking. So page one and page two in this case. Now to LLM, so so this is nothing but context builder. So this is kind of context to LLM. Now fourth step is LLM. So to LLM, what we'll do, instead of passing this entire PDF content, we'll pass this to LLM. Okay, will be knowledge base. And then user query, what user is asking, that also will pass. Okay, how to fix sound issue. Let's suppose this is a user query. And these two are known as context. So context contains whatever knowledge base you have and what is user asking. And then you pass prompt to LLM like, okay, generate answer for the user query based on the KB provided. So these three things will build a context. So that is nothing but context builder. And then we'll ask LLM to generate the answer. Once LLM generate the answer, we'll have some implementation to validate, okay, whatever LLM has generated, whether it is correct or not. So you get a user query, you embed it, find the closest match from vector database, build the context. So the context builder is nothing but whatever knowledge base you've retrieved from database, whatever user query is there, and then what prompt, what you want LLM to do, we pass that to LLM. And then once LLM generate the answer, we go through some validation mechanism. It can be LLM as a judge, it can be semantic validation. There are multiple form of validation. And then we go and generate the final answer. So this is RAG architecture, which is just on high level, and we are going to discuss this in detail. So this is completely about this. Now we are going to discuss embedding model, which I'll be uploading in a separate section. Thank you, everyone.